Hi students, in this session let us learn what is modulation process, types of modulation. Okay, so first we have to know the definition of modulation. So here it is defined as some of the characteristics of a signal which is named as a carrier is varied in accordance to instantaneous values of a signal which is named as a baseband signal. Okay, so this is the definition of the modulation. So some of the characteristics of a carrier signal is varied in accordance to the instantaneous values of signal which is a baseband signal. Okay, now what are the characteristics? So here the characteristics are three characteristics. Any signal having three characteristics. One is amplitude, next frequency, and another one is phase. So while doing modulation, only one characteristic is varied and remaining two are constant. For example, if you take amplitude modulation means amplitude is varies where the frequency and phase constant. Coming to frequency modulation, the frequency is varies where the amplitude and phase of the carrier is constant. Coming to phase modulation, the phase of carrier is varies and amplitude and frequency of carrier is constant. Okay, now here we having a circuit which is called as a modulator at the transmitter side. So here you have to apply two input signals. One is named as baseband signal and there is carrier. Let us assume the frequency of baseband signal is FM and frequency of carrier is FC. After doing modulation, you get a signal which is named as modulated signal. Okay, modulated signal. In generally, the FC is greater than or much greater than FM, where the FM is around 20 to 20 kilohertz. Okay, so FC is varies depending upon type of modulation. So if it is different for AM modulation, it is different for frequency modulation. Okay, so depending upon the modulation, the FC is varied, but the condition is FC is much greater than FM. Okay, so let's go to types of modulation. So here the modulations are classified into two types. One is continuous wave modulation, or it is also called as analog wave modulation or analog modulation. Okay, analog modulation. Coming to another type, which is pulse modulation. Okay, so according to the definition, the carrier signal characteristics is varying according to the baseband signal. Okay, so here the main difference of continuous wave and pulse modulation is here the carrier is analog, but in pulse modulation the carrier is a train of pulses. Okay, so let us see how it looks. So let us assume a carrier signal, x-axis is time and y-axis is magnitude. Okay, so actually if the frequency is more, means here the waves are very close to each other. Okay, so this is the carrier wave. And next, coming to carrier wave in pulse modulation, which is looks like a train of pulses. So depending upon the type of carrier you are taking, the modulation will be changes. Okay, so x-axis time and y-axis is magnitude. Okay, so here this is the difference between continuous wave modulation and pulse modulation. Okay, so again the continuous wave modulation is classified into two types. So continuous wave modulation is classified into two types. One is amplitude modulation and angle modulation. I already told that if one parameter is varied and remaining two parameters the characteristics are constant. I already explained depending on this. So it can be classified into amplitude modulation, and these two modulations are named as angle modulation. Okay, so angle modulation, again this angle modulation can be classified into frequency modulation and phase modulation. Okay, now let's go to the pulse modulation. So in pulse modulation the carrier is train of pulses. Here it is classified into two types. So depending upon the either it is analog or digital type. So here the pulse modulation can be an analog modulation or digital modulation. So coming to analog pulse modulation. So here in analog pulse modulation, here we having three classifications, that is pulse amplitude modulation, pulse width modulation, and pulse phase modulation. Okay, so here the pulse amplitude is varying and here the pulse width is varying, here the pulse position is varying. Okay, so this type of modulation is called as analog pulse modulation. And next another one is digital pulse modulation. So in this digital pulse modulation, we having PCM, which is named as pulse code modulation. So what happens for pulse code modulation? The input is analog. We are getting an output from this block. Output is a digital which is zeros and ones. Okay, so input is analog and we are getting an output which is in the combination of zeros and one. So it looks like a code, something like a combination of ones, zeros. It looks like a code. So that is the reason it is called as pulse code modulation. Okay, so again one more modulation we have in digital pulse modulation, that is delta modulation. Okay, so one more modulation is delta modulation. In the next sessions, we can study each and every modulation in detail, how the modulation is take place, how the demodulation is take place at the receiver side by using different techniques. Okay, so this is about the types of modulations. Okay, so depending upon the carrier, the type of modulation is varied. Okay. And one more thing, we having a different case, that is digital modulation technique. Digital modulation techniques. So in this digital modulation techniques, here input that is nothing but message signal. Okay, message is combination of ones and zeros. Okay, so is in the form of ones and zeros, and this one other input. What is the other input? It should be a carrier which is in analog. Okay, so for example, it looks like the input looks like, for example, 1 0 0 0 1 0. So this is our message. Now you want to modulate by using a carrier, so which is a analog. So then this technique is called as digital modulation technique. Digital modulation technique. Okay, so again it is classified into 3 types. So digital modulation techniques is classified into 3 types. ASK is nothing but amplitude shift keying. Amplitude shift keying. And next PSK, phase shift keying. And FSK, frequency shift keying. Frequency shift keying. Okay, so these are the classifications for digital modulation techniques. Again, this PSK can be classified into few more types, that is binary PSK, quadrature PSK, next 8 PSK. If you want to more value, you can write it as M array PSK. Okay, it might be 16, 32, whatever it might be. So depending upon your application, you can use the respective number. Either it looks like a 2 power n. Okay, this is 2 power 1, 2 power 2, 2 power 3. This is 2 power, okay, you can make it as 2 power 5, 6, whatever. So it depends upon the application. Okay, thank you. If you like, please like, share and subscribe.